Okay, so hello and welcome back. Let's look at simultaneous equations, example number 3. I'll give you two questions or two equations to look at. The first one is 2x minus y is equal to 8. And the second equation is y equals x squared. Y equals x squared plus 4x minus 23. Okay, so what do we do here? Okay, this is equation 1, very clearly. And as you can see, this is equation number 2. We can immediately take equation 2 and put it in 1. Do you agree with me?
Yes.
Right? Why? Because y is already the subject. So if I see y over here, I can put this entire thing in. Do you agree with that?
Yeah.
Alternatively, I could solve for x here or y here and then come up with an equation number 3. But let's not do that. Let's plug this in immediately, right? Let's go with blue.
So there's no need for equation number 3.
So 2x minus, put the entire y in, which is x squared plus 4x, right? Minus 23 is equal to? Is equal to 8. Is everybody clear on what I just did?
Yes.
I took this entire y which I saw and I plugged it in the other equation wherever I saw y. Okay, so now I just need to multiply this out. Tell me what's this going to be? Minus 4x plus 23 is equal to 8. Okay, I'm going to take everything to the other side now. There you can see that's going to be what? 2x minus 4x is what? Negative 2x. Take it to the other side as positive 2x. Okay, that negative x squared becomes positive x squared on this side. And I've got 23 and 8, which is going to give me 15 positive. Bring it to the other side is negative 15 is equal to 0. So if I read this mathematically again, I now read it as factors of 15 that I must subtract to give me 2, which is going to be 5 and 3. Well done. Sorry, it's grade 9 to be honest. Okay, so that's going to be positive 5, negative 3, and therefore my solutions are what? Come.
Positive 3.
X equals positive 3 or x equals negative 5. Right. So now let's just go on to the next screen quickly and let's write down that first equation. Okay, so now we've got values for x equals 3, x equals negative 5. Let's write the first one there. 2x minus y equals 8. You can either go back to the previous one and immediately substitute 3 in this, and 3 in there, and 3 in there, and then you will get a value for y. Alternatively, you can find an easier equation which implies the following. This here you can say that y is equal to, right, 2x minus 8. Now if I want to get that, I need to substitute in my x values, which the one x was 3 and the other x was minus 5. So I got y equals 2 into 3 minus 8, and y equals what? 2 into negative 5 minus 8. And what is this equal to? 6 minus 8 is minus 2, and that's minus 10 minus 8 is minus 18. So if I state this as a set of coordinates or solutions, I now say that my first solution set is 3 and negative 2, and the second set is going to be negative 5 and negative 18. I want you to try this with the other equation as well, which is x squared plus 4x minus 23. Y is equal to x squared minus 4x, was it plus 23? And now you substitute 3 in there. 3 squared minus 4 times 3 is what? Plus 23. What does this give me? That's 9. 9 minus 12 is negative 3, isn't it? Plus 23 gives you what? Sorry, this is plus 4x. What does that give you? Something doesn't seem right there.
It's negative.
It's minus 23. Okay, so that's my fault, but it's fine. Just let me get an eraser. Okay, and the others was plus, and then you tell me what we get. What do we get? 9 and 12 is what? Quickly?
21.
21. 21 minus 3 is negative 2. Is that the same as what we got here?
Yeah.
Okay, and if you substitute in the other value, what was the other value? Negative 5? Negative 5, let's put negative 5 in here. Negative 5 all squared plus 4 times negative 5 minus 23. What does this give me? Positive 25 minus 20 minus 23, and that's going to give you negative. Positive 5 minus 23 is going to give you negative 18. So clearly you can see negative 2 and negative 18 are valid solutions, right? So you can back substitute into any of the two equations.